Thanks for being here. Let me start by getting your name and title.
So I'm Prashant Pathak, working as principal researcher and project lead in product development research group of Tata Steel R&D. Yeah, I'm based at Jamshedpur, India.
And then can you remind me of the product name that won the award this year?
So
Tata?
the product is design and development of hydrogen resistant steels for transportation of 100% gaseous hydrogen.
Can you talk about the team that was involved in developing it? How many people were involved?
Yeah, to be honest, it is a big team comprising of people from R&D, technology group, automation, steel making, and then pipe manufacturing.
Pipe manufacturing.
Yeah.
So a lot of different people coming
Right,
together.
right. Yeah. So big team which have contributed along the entire journey towards development of this particular grade for hydrogen transportation.
Can you speak to the core problem that your product was solving? Like, what was the status quo before?
Yeah. So as hydrogen economy is evolving, there's a need to develop solutions which caters to the requirement of infrastructure that is being needed for the transportation of hydrogen across the long distance transmission. Now, principally, the existing materials that are in place suffers from a phenomena called hydrogen embrittlement when the steel comes into the contact with hydrogen, resulting in deterioration in various properties, including fracture toughness, which is one of the critical properties that is required for a material to sustain when it is under high pressure and hydrogen atmosphere. In this particular development, we have developed a steel. Specifically, the intent was to develop a microstructure that inherently has a higher resistance to the hydrogen embrittlement. And this was achieved through judicious selection of steel composition and process parameters involved during the different stages of product.
How big of a problem is that, like the embrittlement that you mentioned?
Yeah, so it's one of the biggest problem, or I would say it is a major technical challenge that the material experiences in presence of hydrogen. Providing this kind of a solution is definitely going to boost the steel industries towards catering to the solutions for hydrogen transportation over longer distances.
Can you speak to where the product is in terms of commercialization?
So the product has been rigorously tested at external laboratories, one of the renowned testing laboratories for hydrogen related tests. Now it is up for the commercialization. Yeah, so we have taken the complete plant scale trials where we have developed complete in-house capabilities to develop steels in hot roll condition as well as in form of pipes.
So you mentioned that the hydrogen embrittlement was a big problem. Is that one of the more rewarding aspects as you're targeting like a pretty standard, pretty common problem?
So this is one of the major problem that material is encountering, and here specifically through the advanced alloy design processes, thermomechanical simulations and laboratory scale trials, we have developed a product which should last long in hydrogen related environment. The microstructure, as I talked about, is typically a combination of acicular ferrite and polygonal ferrite with the dispersions of nanoscale precipitates, which are typically niobium-rich precipitates. These niobium-rich precipitates helps in entrapping the hydrogen atom as it diffuses into the steels. Typically, hydrogen atoms have a tendency to get accumulated in the most vulnerable regions of steel, and this is what we are trying to attempt, to arrest the hydrogen atoms through the presence of nanoscale precipitates and limits its movement to the vulnerable sites.
Can you speak again about next steps in terms of scaling from now?
So we are already in discussion with the energy-related organizations such as GAIL, IOCL, and we are also having tie-up with the elite pipe manufacturers as well towards the supply of this material, which directly goes into the project which involves the hydrogen transportation.
That speaks to like one of the big challenges that they face.
Yeah, sure.
That's all for now. So thanks again for your time and congrats on the win.
Thank you so much. I would like to at last acknowledge R&D World for giving us this opportunity and giving us this honor to get this most prestigious award, which is a testament to Tata Steel's commitment towards developing solutions and products for a sustainable energy future. Thank you.
Yeah, you're welcome.